Hi guys, we're on to the next lecture in Python for people that want to be aerospace engineers. We're going to look at something a little bit new today. So we've spent a lot of time working using Jupyter notebooks. Now Jupyter notebooks are actually the second means that I used, we'll say the second framework in which I learned to write code. The first integrated development environment, or IDE, that I learned to write code in Python is using something called Spyder, Spyder. Now, Spyder is very similar in its setup and feel to MATLAB. MATLAB is a really expensive piece of commercial computing software produced by the MathWorks, and I've been a recent convert from MATLAB into Python, so it was useful for me to have something that felt similar to the way that MATLAB feels, and that's what we're going to look at today, which is Spyder. It's hard for me to really summarize when you should use Jupyter notebooks and when you should use Spyder or another integrated development environment. I'm just trying to give you the options and show you how these different tools work. And hopefully you'll sort of learn when it's a good idea to use one, whereas it's a good idea to use another. I often find myself writing functions and modules using Spyder and use it for sort of playing around with code. Although I say playing around with code, I often end up using Jupyter notebooks to prototype code because I can see things very quickly. It's just a different set of software to work with. So the way that we access Spyder is through the Anaconda Navigator, as before. So we've got all the things that we've loaded up previously. So we've previously been working using Jupyter notebooks. We can also, we'll only ever use these two for this course. I've in fact never used any of the other ones of these with the exception of Jupyter Lab. But there's lots of other things we can use that are inbuilt to Anaconda. But if we click launch on Spyder, it will load up a Spyder window for us. So let's load this up. Here we go, this is Spyder. Oh, this background's not particularly helpful. So because that looks very funky. Let's give this a plain black background behind this. Now I use dark mode in my variant, or in the way that I view Spyder. So this is why I can make it sort of invisible and have me appear behind it. If that starts to be a little bit distracting, then we can think about give me some feedback on this lecture and I'll change that. I realize that the top of this is not visible, so let's change that a little bit because we're going to want to see how I do various things here. So let me just make this smaller. There we go. You can now see all of the important things. There's a small bit of the window cut off, but I've not included it there. So there we go. This is our Spyder window. It will normally tell you if you need to make an update or if there's an update available when you first load. So this is telling me that I'm using Spyder 4.1.4 and it tells me I can update it if I want to. I don't really care to update to this one just yet. I will maybe at some point in the future. So let's click to quit that, and we immediately are presented with this IDE. And if you've used MATLAB before, you'll sort of realize that a lot of this is quite familiar. So we have a space over on the left-hand side where we can write scripts or we can write modules and functions. We've got this object, this window up here, which can be either a variable explorer, it can give us some help. We can look at plots or we can look at files in our file system. And we've got what's called an Ipython terminal. So this is slightly different from the terminal that you would have had if you're on a Mac and you do command terminal. And it's different from the terminal that you get in Anaconda. We say it's called an Ipython terminal. All that actually means for our purposes is that we can use all of the same instructions that we would have used in a Jupyter notebook, because Jupyter notebook can use those Ipython commands. So the simplest way to use this setup, let's just make a very first important point actually. Up here it tells me the current file or the current path that I'm working in. I could also get this by doing pwd, which is short for print working directory. It tells me that I'm working in users Harry Smith. Now that's not where I want to work at the moment. I want to be working in an area that's sensible and where I can save things that I'm doing. So because I've got an annoying file structure on my work iMac, I've got to change to a different, the way that you would probably want to do is click on here and you can browse and choose a new working directory. So I'm going to choose to work on my hard drive, users, Harry Smith, and the place that I'm going to work is in the folder for this course. Okay, so introduction to the profession, and I'm going to work in a folder called Spyder, which I already started to work in a little bit earlier just to check that everything worked okay. I don't want to use the help here at any moment, so I'm going to have a look here at what the variable explorer is. And we'll use this in conjunction just with a little exercise down in the command window here, or the Ipython console. I'll sometimes call it the command window. That's my old roots as a MATLAB hacky programmer showing. But if we type things down here, we can do some very basic operations. The simplest way is to treat this just like a calculator. 1 + 1 gives me 2. Okay, didn't save anything in terms of variables. I could just do a is equal to 1. And we see immediately I've got a new variable, which is an integer of size 1 and has value 1. B is equal to 2. I've now got 2 variables up here. And this is where we can recognize that Python assigns the type of variables automatically as we go along, because it recognizes that 1 and 2 are both integers, so it assigns these to be an integer variable. If I did a is equal to 1 point, I don't even have to put anything. I could just put 1 and a full stop. It then recognizes that's a floating point number, and then says, okay, well, it's going to be 1 point something, so it can be a floating point number from that point forward. I can then assign new variables to, say, a divided by b, and we see we get 1 divided by 2, and it has to be a floating point number here because it is a floating point number, because to do 1 divided by 2 we get a half, so it has to be a float. If I did 1 multiplied by 2, so d is equal to a multiplied by b, this is a float because if I have the product of an integer and a float together, I then end up with the product being a float in this case. So there's no easy way to clear all the variables as you would do in MATLAB. You do clear. You type clear. Let's try that here. See what happens. It just clears the window for us. That doesn't help us. It doesn't remove these variables. Easiest way to do that in Python is just to restart the terminal. So if I close this tab here, there's a couple of ways I can do this. I can start a new terminal. So that one there does remove all variables. I didn't know that. That's news to me. So let's click on this. Removes all those variables. So that's something new for me learning. I haven't used Python for a while. I could make a new terminal window over here. So I can click here, or I could just press Command T on the Mac, and that makes a new terminal window over here. So these are 2 separate consoles that are running 2 separate instances of Python. So if I do a is equal to 1, b is equal to 99.5, I've got these 2 variables over here in this console. If I click over to this one, I try and see what a is. It doesn't know what it is because this is a whole separate working instance of Python that only this one over here knows what a is. So this is quite handy if we want to run code and do 2 separate operations using exactly the same set of, say, methods and functions, but we want to do it on different input numbers, for example. And just to confirm over here, I'm still in the same directory. So that's my working directory is in this same Spyder console. And over here, that's the same working directory in this Spyder console. So let's do clear to make this clear. And I'm going to use the new button that I wish I'd learned about before to clear all of those variables. And I never want to show that again. So let's, sorry, it's got a very strange email. So let's have a think about some more things we can do. So if I want to make a list, for example, a is equal to 1, 2, 3, 4. Okay, I now have a list object which has got these 4 items in it. I could do the same. B is equal to range 4. Okay, that's now just a range object. That doesn't particularly help me. I should have done b is equal to a list range 4. There we go. So I've got two lists that are similar. They've got the same length, but one is the numbers 1 to 4, one is the numbers 0 to 3 here. Let's try and do some NumPy things. So let's say C is equal to an NP array of the list that was A previously. It doesn't like it because there's no NumPy available here yet. So let's try import NumPy as NP, and we'll try the same thing again. So there we go. We now got an array of integer 34 for C. So let's see what works here. I suspect now, let's just do clear a second. So I've got a clean terminal window. If I try to see, I can see what C is, I can see what A is, and I can see what B is. And I can also use the other inbuilt things within NumPy. So I could say D is a NumPy let's try this. So I've now managed to make okay. D is now a random array going from 0 to the highest number that's not inclusive being 10. So that's the integers 0 through to 9, and it's a 20. It's got 20 parts to it. So I've just used the numpy.random integer method there. So let's clear this again. If I clear all of these variables, I've now no longer got access to, say, D, or the thing that I made. If I press the up arrow on my keyboard, it allows me, I realize I've done this a couple of times and not explained it. The up allows me to look at the previous commands that I typed. So that's similar to DOS key, if anyone remembers what that is, but that's probably beyond anyone that could be watching this. Let's try and reset D by doing D is equal to numpy.random.randint. Doesn't like it. And that's because when I cleared variables, what I'd also cleared was import numpy as NP. Okay, it doesn't show up here as a variable because it's not a variable. There's no way of showing what I've got. No, there's no way of showing that. But within this working console, I'd assigned the object NP to be equal to NumPy, and that's what enabled me to use all of those inbuilt parts of NumPy. So, oh no, I don't want to do that. I just typed clear in the wrong place. So we're going to be using both Jupyter and Spyder quite a lot over the next few years of your academic careers. Let's just look at some of the ways that are helpful to use Spyder. So I'm going to clear this console. Let's remove this one because I don't need to see it. And let's just have a look in here. So I started earlier, I wrote something called myfunct.py. Let's just delete both of these. Oh, I pressed the wrong button. So I'm going to highlight them both, right click and click delete. And I want to delete them all. That didn't work. Do you really want to delete myfunct? Yes. Let's see if I wonder if I now go out of this directory and go back into it. They've been removed, yes. So even though I deleted them, this display here isn't refreshed, I believe. So that's why, actually. I wonder if there's a way of refreshing it up here. So if I go up, I go to Spyder. It doesn't appear there's an easy way to refresh things in here. So if you delete something and you find it's not deleted or it's not reappeared the way that you would expect it to do, then that's because actually just go out of the folder and come back into it. So I'm going to right click, I'm going to make a new module, and we're going to put some things in there that we might want to do more than once. And remember, a good, lazy but efficient engineer remembers that if they want to do something more than once, then they will write a script for it, or in this case, we'll write a module and we'll put some method or put some functions inside that will help us to do that. So we'll do module. We're going to save this as myfuncs.py. Okay, so as soon as I do that, it's created myfuncs.py, which is over here. it still doesn't exist in here. So there's no way of refreshing this, I don't think. If someone wants to Google how you can refresh this and let me know, that would be great. But what I'm going to do instead is I'm just going to go here, click up to the parent document, up to the parent directory, and then I'm going to double click on Spyder again, and we can see we've got myfuncs.py, and the associated logo here tells me that it's a Python script. So looking over here, there's some information at the top that tells us a little bit of information about where the Python actual interpreter exists. We don't need to worry about these two lines too much. They just exist in anything that we create. And then automatically creates a doc string for you. A doc string is any information at the top of the file that's contained within 3 successive quotes, or a pair of 3 successive quotes at the top and the bottom. And so I'm just going to put in here, this module contains some functions that I will use more than once, so I'd like them saved. I'll save that. So now if I do help myfuncs, doesn't know what to do, okay? Because even though we've got this object here, so let's do pwd, and we're in this areas where we've got this method up here, we haven't imported it yet. So just as I couldn't do the same help numpy, doesn't know what this is. So what I can do instead, I can do import myfuncs. There we go, and I can do help myfuncs. There we go. Gives me the name and a bit of a description here. Okay, this is not necessarily how we should be formatting a document string or a doc string, but it's a good working start for us. So there's some things that we might want to do, like we say, more than once. So I'll just give you an example of how we can create a function within here and then access it using the terminal window, or using the command window, or Ipython console is what it's called here. I'm really bad at remembering the correct name for this, but you should understand what I mean. So let's say we find ourselves often wanting to take a number, be it an integer, float, and we want to add a single 1 to it. So we'll say, okay, we want to do this more than once, so we'll do def add 1 to an input number. I can have a doc string for this as well. So if I type three quotes, it will give me the option to generate doc string. So I'm going to click on that. Here we go. This is pretty handy. So parameters, inputs, type can be, let's say we want to input any form of numeric. So we'll put numeric. Our description is going to be a number to have 1 added to it. And what it's going to return, doesn't know how to return anything yet. So in fact, what I'm going to do is I'm going to remove this document string, because what I can see this automatic doc string generation does is it looks at the inputs and outputs and puts some stuff in here. So we're going to get rid of that. So I could do this. I could say my output is equal to input plus 1, return output. I save this by doing command save. If I've edited in here and I've got nothing saved, a little asterisk will appear at the top. So let me get rid of that and press save. Over here now, let's do clear to get a nice new window. If I do myfuncs dot add 1, and I'm going to put 1 here. Output, it gives me 2. Okay, so because I've saved this, it's automatic. I think it must have automatically re-imported myfuncs over here. I need to have a think about how that works. But fundamentally, if we save changes here, we're then able to use them immediately over in the console. So let's try doing help myfuncs.add 1. Doesn't know anything about this. So let's go over here. And in fact, let's just think about what we've done here. So we've got output is equal to input plus 1. I could just replace this output line down there. Let's just check this still works. I'll save this. It still does the same thing. Let's just confirm by putting a bigger number. Does the same thing. A really trivial example, but this will help sort of understand how we create this module, and then we've got this function within inside that we can use. So if I try to create a docstring again, let's go down to generate docstring, click on that. There we go. So input, let's say type a numeric, and the description is going to be a number with 1 added to it. Returns single output numeric input plus 1. Save that, and if I now try and do the help on this again, there we go. Okay, a number with 1, a number you wish to have 1 added to. That doesn't make any sense. There we go. So we've now created our first module with a function inside that we can use. Doesn't seem particularly useful just yet because this is not a, if you wanted to add something that's fairly trivial to do using a single line of code yourself. So let's think about something else we might wish to do. So let's say we find ourselves often presented with a big list of numbers and we want to find out what the 3 largest are. This could be if you want to find the first, second, and third place based on performance in a given list. So say you want to find the 3 biggest items in a list or a NumPy array, and you want to be able to return what they are and where they occur. So we'll create an object to do that. So let's say it's clear. Let's say my list is equal to np dot array 1, 2, 3, 4, 5, 6, 7. So I want to be able to put this list into a function that exists over here using exactly the same syntax that we used to do the add 1 to it. So I'm going to make a new function over here. I'm going to call it define find 3 largest. And we're going to put an input in. So to find the 3 largest, we need to do 2 things. We need to sort that array from biggest through to smallest, and then just pick out the first 3 parts from that. So we're going to want to use something from, in fact, we don't even necessarily need to sort it. We just need to know where those things occur. So I happen to know that it's easy to do that in NumPy. So I'm going to do import NumPy as np over here and show you something called numpy.argsort. I think we might have used it previously. So let's do help numpy.argsort. Okay. Returns the indices that would sort an array. So for example, let's say I've got a is equal to 1, 2, 3, 5, 1, 2, 3, 6, 5, 4. That's my A. I'm going to do np.argsort a. And this says the order to take them in is take the first one, 0. Take index 0, which is correctly 1. Take index 1, which is 2. Index 2, which is 3. Index 5, which is the last one, which is 4. Index 4, which is number 5. And index 3, which is number 6 over here. Okay, so this gives me the sorted parts over here. So if over in my script up here, I know I'm going to often be using NumPy, I can import it over here. So I can do import NumPy as np, and it means that I can then, with anything in here, I can then use np to represent NumPy. So I'm going to get sorted indices is equal to numpy.argsort input. And then what we want to do is we want to print out those top 3. So we'll do, let's put some comments in here to show what we're doing, because that's always a good idea with code. Then we'll do print the top 3. we'll do print, and we'll do an F string. The largest, I can see an error in the way that I'm thinking about this, but we'll say the largest item is input, and I want sorted indices 0 at location let's save that. I think that's got a closing quote. That's right. I'm just going to print this out and just show you. I've realized there's an error in the way that this would work because I have sorted this from smallest to largest and I've picked the first one. So there's two ways I can solve this actually. So let's say over here, let's do my functs find 3 largest A. The largest item is 1 at location 0. So I've chosen to pick the smallest. So there's two ways I could do this. I could take this array, I could do np.flip, which is going to take the indices and sort them from largest to smallest, smallest to largest, and then turn them into the indices that does it the other way around. So if I now try this, it does this correctly. It finds the right one. Alternatively, I can get rid of that bit I did over here, which flipped it. And I could say I want the last item in that array. So that's a -1 over here. And save this. So I've now got the original sorted index. And over here, let's click. There we go. It's got the right answer. So we'll keep this way around. Let's do the same over here. Print this out twice. So I want to print out the second and the third largest item. So if I want the last index, I want -1. I want the second last index, which is -2. Third last index, which is -3. So let's do these over here. So I've saved these and we'll try. There we go. 6, 5, and 4, which is correctly pulled out. So we could also do over here, let's do return sorted indices. And we're going to put the first 3 indices coming back out. So that's from the very first one through to the 4th, but not including it. So in fact, I should put that to 3 there because it's 0, 1, and 2 I want, and not 3. So let's try and run this. There we go. So it's printed these out, and it's also returned me 0, 1, and 2 here. So that's going to be really helpful for us if we want to sort an array. Let's think about if I now made A equal to 1 and 6. Something that's only got 2 items. Let's try and run this again. Doesn't like this. Okay, it doesn't give us a very useful error. It says index -3 is out of bounds for axis 0 with size 2. So what it's done, it's managed to print out the first and the second part, but it's had an error with printing out this one here. So if we go back up, we can see this is the error that it's given us. And we can see here that it managed to print out those first 2 lines. And it's because it can't find the third largest item in a list that only has 2 things. So we can immediately go here. We can just put a wrapper around this whole chunk of text. I'm going to say if the length of input is greater than 2, then we can do all of these things. I'll tell you what we'll do instead, actually. Let's go here. Let's say if len input is greater than 1, then we'll print out the second largest item, and we'll do here if len input is greater than 2, print out the third largest item. And let's return the sorted indices of all of them down here, because otherwise that's going to throw an error. So let's run this, and let's try running this again. There we go. So it only prints out the first 2, and it no longer gives us an error with this piece of code here. This isn't a particularly useful piece of code, but it's just showing you how to think about how we write functions that we might want to do more than once that we can then use again and again and again. Let's say we often want to make a quick XY plot of some data. Now, the way that we would do that before, we'd import matplotlib.pyplot, we create a figure, and we then plot the data, and we'd give them X and Y labels. So let's say we want to do that quite a lot. So we'll do import matplotlib.pyplot as PLT, and I'm going to do define quick XY plots. So the things that I want to put into it, you need to have X and Y data, and then I'm going to say X label is going to have a default value of X. Y label is going to have a default value of Y. So what this quick XY plot needs to do, it needs to make a figure, put some data on it, and then label the X and Y axes. So we'll do plt.figure, plt.plot, XY, plt.xlabel, and then this is going to pull out whatever is either going to be X if we don't tell it anything, or it will be X label, which could be a string that we insert. plt.y label, and lastly, plt.show. Let's save that. So let's do clear here. Okay, it's just try. When I did clear, it reloaded everything here, and it said it's reloaded this module over here. And I know that because it's caused an error here. It says module not found, no module name matplotlib.pploy. I see this error all the time because I always end up accidentally typing pploy rather than pplot. So if I save that and try and do a clear again, everything's going to work over here. So do I have NumPy available? I think I do because I think this is run, but let's just check it out. So let's do a is equal to np.array. Yeah, so I've got NumPy available to me now. So let's do a quick sign plot. So we'll do x is equal to np.linspace from 0 through to 2 times pi, and I want 1,000 points. Y is equal to np.sign of x. And then what we're going to do, we're going to do this quick xy plot. So we'll do myfuncs.quick xy plot xy. Okay, I was expecting a plot to appear, but it hasn't. So let's see if this helps us at all. Figures now render in the plots plane by default. To make them appear inline in the console, uncheck mute inline plotting in the plots pane options panel. I sort of understand what that means, but it's a real pain to do. But what it's telling you is that our plots appear up here. So we've got our quick XY plot. Easy way to get rid of this is to use what's called an Ipython command. So I type a percentage, and I'm going to say matplotlib interactive, which is very similar to what we did using Jupyter anyway. Oh, it doesn't like that. Let's change it to auto. Let's try that. There we go. So it's now changed the way that plots are going to work. So if I do clear again, and if I try and run this now, my plot has appeared on my other monitor. So let's drag this over. This has brought a plot in that I can move and I can resize and I can do things with. So that's really helpful for me. So we've got this X, Y. Let's say I want to call this X and I want this to be sign of X over here. So over in my command, I said X label is going to default to X, Y label defaults to Y. So I can provide both of these labels. I can say X over here and Y by including these as positional commands or positional inputs, and it's correctly changed both of those to uppercase and lowercase. Let's just close both of these down. What I can do instead, if I only want to change one of them, I can say Y label. So I can use this keyword here, equals sign of X. Let's run that, and then we've got sign of X appearing in my thing. So this is just a handy function that I've made to be able to plot things. Let's see if we can use LaTeX formatting. So LaTeX is spelled L-A-T-E-X, so be careful when you Google it. Let's see if this works. There we go. It just gives me slightly nicer formatting for my label there. Okay, it gives me LaTeX formatting for my sign of X and X down here. Okay, so we've produced something that was able to help us plot. This is going to be useful in the future just to be able to produce functions that help us do different things. On Wednesday in class, we're going to be looking at some slightly counterintuitive problems that we can try and produce solutions to using computational methods. So it will be your choice of whether you do them in Jupyter or in Spyder, but hopefully now I've given you an introduction to different means of just looking at coding, a different framework in which you can write code and you can imagine how to solve a problem, and different ways we can do things. And hopefully this is something you'll be able to use in the coming years as you go into the rest of your academic careers and aspire to be the best engineers you can be. If there are questions, please remember to pop them on Slack, and I look forward to seeing you guys on Wednesday. Take care.